article discussions. As per Atal norms, we have to have discussions on the article general article. For that, yesterday we have made two journals which are related to this topic industry 4.0. So the hard copy of these printed version is also given to you in your folder. You can see that what is expected, what they want. They want that whatever topic is being discussed here, for example, 3D printing, CNC, laser, whatever. So one paper we will be making groups. Number one, number two, these groups will be discussing from these papers. So this is our article discussion session. So we will first create the team members. So as we have people from various branches, so we will try to have people from same branch. We can make a group accordingly. Civil, mechanical, electrical, CSCC सब मिला के एक ग्रुप बना सकते हैं. चाहे तो हम खुद से एक ग्रुप क्रिएट कर सकते हैं. तो अगर आप लोग कहेंगे तो हम एक साथ अगर आपकी चॉइस है तो 4 लोगों का ग्रुप बना लें और फिर वो लोग आपस में आर्टिकल डिस्कशन करेंगे. आज हम पहला आर्टिकल डिस्कशन करेंगे और उसके बारे में एक समरी का मैं फॉर्मेट आप लोगों को दूंगा. उसके बाद यानी कि परसों वेडनेसडे को हम एक और आर्टिकल लेंगे फिर उसका डिस्कशन करेंगे.
Unfortunately, today we are not having all those certifications for editing because people are not open to use this particular thing because they are not aware of it. They do not understand the challenges of conventional process and how they can rectify those issues with the help of editing manufacturing. So this is why it is equally important to use those know-how as well as the certifications to utilize at a greater scale. Because if we are using it for just 20%, this will not go in future. And the problems which are existing there with the conventional approach, that will still be there. So for a long time, that will not resolve for a long time because they do not have the clear resolution of that particular problem. So there are also the software solutions. So we are having Altair solution for additive manufacturing. Like I will share an example in my upcoming slide, but I can relate this to one of the examples. Like if you have one part which is a single block, right? Let us take an example of this chair. If this chair is like fully solid from here as well as here, you cannot see any kind of space in it. So this is completely solid. This is robust. This is very strong chair over here. But at the same time, if we do some design analysis, topology optimization of this particular space, then what will happen? The chair will reduce its weight, and this chair can be utilized for the same purpose. So the utilization of resources can be made with the help of design. So design is equally important as the material, because if you design something and that design is not having all those parameters in the consideration as per the process, what process you are going to use, then what will happen? You will not able to create optimized product, and that optimized product will have the efficiency. But if you are doing it conventionally, considering all, maybe it will be having good efficiency, but it will not be equal to the optimized process. So, in order to achieve more efficiency, we need to do the optimization. So, this is the particular share. If you look at the different utilization in application. So, if you see today, it is the global data, not the Indian data. If you see today, people are using mostly the healthcare and the aerospace because it is having power to do the customization. So customization is the key in additive manufacturing. You can see the rest of the charts where you can see the using rate. So it is having everywhere, presence in everywhere, but majority of the parts are from aerospace and the aviation. So these are the different users. You can name any user. They are using it for various purposes. Some may be using it for prototyping, some may be using it for end-use parts, some may be using it for medical applications, some may be using it for medical devices. So there are two different things, like one is the medical device and second is the medical implants or healthcare thing. So there are the different companies for the different purposes. So what are the different solutions we provide? So these are the different solutions we are having, like from technology, from sizes, from material, from value add, and know-how. Right?
Sir, sir, go to the previous slide. Go to that one. Statistics. एक और इससे पहले ये this one. What it signifies?
Like any product, like today if we are talking about cars, okay, any product, if we talk initially about it, it seems like passionate, right? The same thing happens with building. So initially it evolves and having some height, and with that height achieves the maximum peak of usability. Right? The technology was used for this, blah, blah, and then achieve the maximum height. In the medical device.
And on that height, 5 to 10 years.
Yes.
Majority of this 5 to 10 years. What it signifies?
It signifies
it is a pattern, sir. There is a pattern. 5 to 10, then
yes,
2 to 5, and then less than 2 years.
So I'm telling you, the technology is very big. If you talk about the industrial revolution, it was roughly 17th century, right? But if we compare with that, technology is very new. So it was evolved in 1980. The very first technology was developed in 1980. After that, there was no improvement further. After in 1989, there was sudden improvement in that, and that was the time it achieved the height. Okay, sir. After that, like for a period of 5 to 10 years, it was at that particular peak, but globally, not in India. So in SLA process, you can achieve very great accuracy. It is the oldest process, but it is having great accuracy till today. So this is a bed which is filled with the resin, and this is a build platform which is having some holes over there. This is a software that is preparing the file. You can create design in any software like this. program can be exported onto the machine in the form of G-code file. With the help of UV light, it is getting cured at the designated area. So this is material jetting, where material is filled inside the head. So it has been represented with the single nozzle, but there could be the multiple nozzle in the head, and that deposits the material. And the material can be cured with the help of fusing lamp as well as some blower like apparatus or some heating from the build platform. So there are the various ways to cure the material. So the material may be POP, material may be resin. If the material is resin, the fusing lamps would be there. If the material is POP, so cooling can happen like this from the build platform as well as the blower. Because if you are directly loading a file to a 3D printer, it will not understand. Because it will, in the back end, will work on some codes. Those codes are known as G codes, SAN codes, and all that. So, on the basis of those G codes, the printer will print. So, in order to generate that G code, you will require a slicing software or the build preparation software. So, that build preparation software may be dedicated for the 3D printer, or that may also be the third-party software. After that build prepared file, which is known as G code file, will be exported to the printer, then only you will get the 3D printed output. So this is just idea video to showcase you the 3D printing process. So where you can see the outer shell has been designed and inner part has been designed. So this is one layer has been completed in this. So this is the FDM process, which is the most simple way of presentation. So this is second layer. So this is how the layer by layer evolution happens, and finally you will get the part.
Sir, there are various machines are available for manufacturing the 3D objects. As we have seen in the industry also, suppose that toys, there are different industries which develop the different which manufacture the different type of 3D object or toy. Why we go for 3D printing? What is the difference? What is the advantage over these two?
So there are various manufacturing processes. For plastic, there is very popular process is injection molding process. So in injection molding, if we compare injection molding with the 3D printing process, so it is very different because in injection molding, you will require a time. If you are creating something, there is in-process inspection available in the machine with the help of lasers. So that can give you the optical results of it. Wherever you will find some like major deviations, the machine will not further work. It will stop in between. So there are various ways of doing it. If you have developed part, you can do a CMM measurement of it, like you are doing in the conventional process. If there are some errors in between, it can be easily rectified with the help of machine. Machine will be having some measurement tools within the machine. So this is how you can do the measurement.
So if we compare with the metallic coating and this 3D printing, so according to which one works better?
In terms of strength?
Yeah, strength, rigidity and all.
Okay. So in terms of strength, if we are talking about metal, like we are considering here metal, okay. If we are considering plastic, there are certain points which need to be considered, but for metal, the strength would be in between casting and forging. It would be better than casting and lesser than forging. But there is another way of it, which is heat treatment. If you are doing heat treatment with the part, you can achieve as good as you wish, right? So there is, like if you are going to compare after the heat treatment, it can be even better than the food. So after this, we are having different technologies. I have not touched every technology, but there are some technologies which are there. So that can be classified in three ways. So because we are talking technologies, additive manufacturing, 3D printing, rapid prototyping. So here I am taking AM systems. AM system means additive manufacturing system. So that can be classified in three ways. One, which is using liquid as a working substance, or liquid based additive manufacturing system. One which is using powder as a working substance, then powder based additive manufacturing system. Third, which is using solid as a working substance, solid based additive manufacturing system. In liquid based additive manufacturing system, we are having SLA, which has been placed over here in the premises. And SLA can be further classified in VLP and LFS. So I can show you the line diagram of this particular technology in further slide. So this technology uses liquid resin as a working substance that can be photo cured to form the composite. So this is the very first developed technology, very first invented technology.
Mostly used, sir. In terms of liquid state, powder, and
All are used. But as per your application, you have to choose.
okay. What about SLS, sir?
SLS is most popular, and in metal it is like with the name of DMLS, it is very much popular. So it is the only technology which is having share of 95%.
Sir, as far as we know that 3D printing is faster as compared to conventional right now.
Again, depend on the application. Like if you want to create multiple parts like mass production, then it is costlier. If you wish to do the customized part, it is very cost effective.
So as per current market scenario, is there any specific area in where in near future 3D printers can be more
Orthopedic implants, aerospace applications, customized parts. These three areas are.
How this medical industry now currently prototypes are being made using titanium.
Actually, for dental applications, there is a material called chrome cobalt, which has been widely used. And for implants, titanium is widely used, but titanium is a bit expensive, so people are transforming from titanium to steel. So 316 cell is there, which has been used for implant. And for implant, there are certain plastics. But with plastics, the process yet not get the FDA approval. So the PEEK material is one of the material which has been approved for implant. But in additive manufacturing process, it has not been approved.
Sir, is there any limitations on 3D printing?
Yeah, there are a lot of limitations.
Like, sir?
If we talk about limitation, then first limitation is if you are going to do the mass production, it is not possible. Second limitation is the manpower and the skills, which are very limited. If you are not skilled to run the 3D printer, you would not get proper output from them. This is why a lot of people say we are in the loss after spending on 3D printing, because they have not invested in the know-how, but they have invested in the equipment. If you are going to invest in the machine, then you should think of investing in the know-how also. If you are not investing in know-how, then you will not get the desired result from the machine.
आपको अभी तक 3D प्रिंटिंग का बताया गया, डिफरेंट डिफरेंट टाइप ऑफ 3D प्रिंटिंग्स हैं, डिफरेंट डिफरेंट उनके यूजेस हैं. सो जस्ट लाइक एनी टेक्नोलॉजी मार्केट भरी पड़ी है इससे। आप बोलने के लिए 7 मेजर टेक्नोलॉजीज हैं, उनके नीचे फिर 50, 100 डिफरेंट कैटेगरीज ऑफ टेक्नोलॉजी है। सबका अपना यूज़ है, सब विद टाइम अपने आप धीरे धीरे आते गए मार्केट में। सर आप लोग चेयर ले लीजिए सर।
इट्स ओके,
ओके
नहीं आप बैठो,
बेटली बेस है, सबकी अपनी रिक्वायरमेंट है, सब अपने हिसाब से फुल कर सकते हैं। जब कोई एक टेक्नोलॉजी फुलफिल नहीं कर पाती है तब एक नई टेक्नोलॉजी बन जाती है। एक ये लॉ है बेसिकली नेचर का कि जब एक चीज़ नहीं सकती घर की कोई नई चीज़ उस पर आ जाती है। सो ये सेम। सो मेरा भी आपको टास्क होगा 3D पेंटिंग में हमारे पास FDM 3D प्रिंटर है, हमारे पास SLA 3D प्रिंटर है। उसके अलावा मैं आपको और भी बाकी टेक्नोलॉजी के ओवरव्यू दूँ कि क्या हो रहा है इंडस्ट्री में, क्या कर रहे हैं और आप लोग कैसे इसको कर सकते हैं अपने अपने रिस्पेक्टिव इंस्टीट्यूट्स। ओके सो सबसे पहले सर FDM आपको पता चला होगा। FDM का मतलब है फ्यूज डेपोजिशन मॉडलिंग। इसको अगर समझना है तो आप सबसे बेसिक चीज़ समझें, आप लोगों ने सोल्डरिंग, वेल्डिंग या ग्लू गन, इन तीनों में से कुछ ना कुछ अपनी लाइफ में यूज़ किया ही होगा या देखा होगा होते हुए। ये तीनों के तीनों सेम प्रोसेस है। हम जो FDM बोलते हैं उसे FDM ना बोल के एक ब्रॉड कैटेगरी में बोलेंगे मटेरियल एक्सट्रूजन। जैसे नाम समझ में आ रहा है मटेरियल एक्सट्रूजन, मतलब मटेरियल एक्सट्रूड किया जा रहा है। अब वो मटेरियल कुछ भी हो सकता है, इट कैन बी वायर, इट कैन बी व्हाट यू से बायोमटेरियल्स, इट कैन बी इंक, एनी काइंड ऑफ मटेरियल। जहाँ भी वो एक्सट्रूजन हो रहा है ये मटेरियल एक्सट्रूजन कैटेगरी कहलाती है। राइट नाउ हमारे पास एक पतली सी वायर है जिसका एक स्पेसिफिक मेल्टिंग टेम्परेचर है, हम लोग उसको मेल्ट करके फ्यूज़ कर रहे हैं, मेल्ट करके फ्यूज़ कर रहे हैं। सेम चीज़ वेल्डिंग में होती है। वेल्डिंग में आपकी एक वायर होगी, आप उसको डिफरेंट प्रोसेस से करंट देके, हीट देके मेल्ट करके जोड़ रहे हैं। अब यहाँ फ़र्क क्या आ जाता है, आप लेयर बाय लेयर प्रोसेस कर रहे हैं। सिमिलरली आपके जैसे वायर हैं वैसे ही यहाँ पे डिफरेंट टाइप ऑफ वायर हैं। प्लास्टिक एक ग्रेड के नहीं होते, हमारी पतली सी पन्नी भी आती है मार्केट में। आपके हाई एंड इंडस्ट्रियल प्लास्टिक्स भी आते हैं, हाई टेम्परेचर इंडस्ट्रियल प्लास्टिक भी आते हैं। सो देयर इज़ नो लिमिट ऑफ डिफरेंट मटेरियल्स। सो सिमिलरली ये मशीन्स भी केपेबल होती हैं हर तरह का पार्ट पेंट करने की। इफ़ यू वांट टू पेंट समथिंग फ्लेक्सिबल, यू वांट समथिंग इन फ्लेक्सिबिलिटी, different type of flexibility, different level of flexibility material is there। आपको नया नॉर्मल पहले आए थे हमारे नॉर्मल फ़ोन, फिर आना शुरू हुआ टच में सेट करता गया, हर दूसरे महीने कुछ नया आ गया, फोल्डेबल फ़ोन्स आ गए। अब हम देखते हैं ट्रांसपेरेंट फ़ोन्स की भी बात होती है, तो अगेन कोई इसमें लिमिट नहीं है। बट ये एकदम से ये स्पीड कैसे बढ़ गई इनकी इनोवेशन की, क्योंकि टाइम तो नहीं लगता है रिसर्च में। तो चीज़ क्या हुई कि उनको तरीके उन्होंने डेवलप किए जिसमें उनको पहले हमारे मतलब आज से 50-60 साल पहले इशू क्या होता था, अगर मुझे ये रिमोट बनाना है तो पहले मैं एक डाई बनाऊंगा, मतलब मेटल की डाई बनाऊंगा जिसमें मैं प्रोसेस करके इसके 1000, 10,000, 20,000 पीस, 40,000, लाखों पीस निकालूंगा। ओके, अब उस डाई के साथ इशू क्या है, ये एक महंगा प्रोसेस है। आपको मेटल पे काम करना है, मैन्युफैक्चर को भी पता है कि अगर उसने एक बार मेरी सीढ़ी बना दी मैं 5 साल तक उसके पास नहीं आऊँगा, तो मुझसे कॉस्ट भी उस हिसाब से लेता है। प्रोसेस में इतना मनी नहीं है जितना वो लेते हैं अपने एंड पे। ओके, अब अगर एक कंपनी 10 से 20 लाख रुपए सिर्फ एक डाई बनाने की कर रही है तो वो कम से कम इससे 50-60 लाख रुपए या 1 करोड़ तक जब तक अर्निंग नहीं करेगी वो डाई थ्रू नहीं करेगी, क्योंकि उसको अपना ROI निकालना है प्रॉफिट के साथ। ओके, अब अगर आप बोलो कि उसको 1 करोड़ कमाने हैं, ये 500-600 रुपये से ज़्यादा का नहीं होगा। और कितना कितनी भी इनोवेशन कर सकते हो, यू आर नॉट बाउंडेड टू एनीथिंग। आपने ये चीज़ देखी होगी, चीज़ें वहाँ पे इनोवेशन वहाँ ज़्यादा आगे जाती है जहाँ पे आपके डिजाइन कस्टम होते हैं। एग्जाम्पल भी देखें तो आप लोगों ने टेस्ला का सब नाम सुना होगा। टेस्ला बैटरीज भी बनाता है, टेस्ला कार से बनाता है। अब टेस्ला ने प्रोसेस अपने इतने एडवांस किए कि उनको कमर्शियल बैटरी जो पहले मिलती थी उनकी जरूरत नहीं पड़ी, उन्होंने खुद की बैटरी डिजाइन, उन्होंने खुद का प्रोसेस डिजाइन किया। पहले पैसा लगा होगा तभी आज के टाइम पे भी 40-50 लाख से कम की पैसा किसी को नहीं मिलती इंडिया में, दिखने को ना के बराबर दिखेगी। वाई इट वाज कॉस्टिंग, बट धीरे धीरे उनकी कॉस्टिंग गिर रही है। दे गो